All right. Thanks everyone for joining. If you're just joining, I'm Sean McMillan. I'm the community manager here at Bishop Fox. I'm joined by Tim Makram Ghatas. This is our first workshop in a while, and it's our first on Sliver. So I'm really excited to kick this off. We're looking to do more of these pretty regularly because it seems like we're sitting on a gold mine with Sliver experts in here. So if you have any questions, drop them in the chat. If we miss anything, let us know in the Sliver channel afterward. Rachel and I will be monitoring the chat so we can kind of help out there as needed too. But that's it for me. I will yield the floor.
Okay. So hello everyone. Like Sean mentioned, my name's Tim. I'm a member of Bishop Fox's Red Team and one of the developers working on Sliver. The goal of the workshop here is going to be to demo some of the features that we're going to be including in our next upcoming release. That'll be version 1.6. Not quite ready yet, but all of the features that I'm going to demo here today are already available online. You'll just need to clone the repository and build Sliver from scratch. But once you've done that, you'll be able to follow the workshop as we go through it. So Sliver, it's a post-exploitation framework that we use internally at Bishop Fox. What we mean by that is it's not a tool that has any exploits like you'd find, for example, in Metasploit, but rather a tool that you would use once you have access to an environment to gain more stable access to it and be able to perform post-exploitation tasks like, for example, enumeration or lateral movement. And so in this workshop, we'll be starting from the very basics, and as we go through the different features of it, I'll try and demo some of the newer tools that we've included in it and give you a few tips and tricks to use it during live engagements. So to get started, I'll quickly share my screen. You should be able to see a shell. This is a small Linux VM I've set up for this environment. Quickly spin up Sliver. Okay, here we go. Is everybody able to see the screen? Perfect. So, Sliver. Essentially, it's a Golang C2 framework. And right now, the shell I'm running in is the Sliver server. In that server, we're going to be hosting a series of listeners, and it's also where we're going to be generating our implants, running commands, and so on and so forth. We also have a client named Sliver-client that is all it basically does is connect to that server to run commands, but all of the activity actually happens on the server itself. If we look at the CLI, we have an interactive help that has documentation for all of the commands that are available. This will change depending on the context. For example, if you're interacting with an implant, the help will show you commands available in the implant versus what it's showing now, which is the server commands. We're going to get started with what we call listeners, which is essentially all of the C2 options that are available in Sliver. Right now, we support HTTP and HTTPS. We have MTLS, DNS, WireGuard, and a few other options. The way you can see what's currently running is using the jobs command. Right now, we don't have any listeners running, but if we spin up an HTTP listener using the HTTP command, for example, you can now see that we have a listener running. You can see the port, protocol, and so on. All of this is configurable. For example, if we look at the help for HTTP, we can specify host, port, and a few options around server timeouts and so on. The next step to get an interactive implant running is going to be using the generate command. So generate is going to build out our implant and embed any options that we specify inside that implant and give us with a binary that we can then run. Again, looking at the help command, there are a lot of options. We're not going to go into every single one of them, but we're going to cover the basics of it and then delve a bit deeper later on. Right now, the goal is really just to get an implant running and show you how you can use it interactively. So for the generate command, we're going to be using an HTTP callback. So you can use either tag B, or HTTP shown here. It's going to be calling back over localhost. The next step is going to be specifying the operating system. So in this case, I'm running on a Linux VM. So I'm just going to specify tag OS and the architecture, which is AMD 64. Now, since this is a live demo, we're also going to be removing some obfuscation and adding some debugging so that we can see what's happening behind the scenes when we actually run the binary. So if we go ahead and generate this, you can see in the background, the server is going to be embedding whatever parameters we've specified inside the implant and then generating it. And after a few seconds, we should see a binary pop up. So if we just give it a second, up, okay, that's great. Let me just quickly restart this. Okay, so all right. Just one small second. I'm going to switch to a local version instead. So same command as previously, our generate. This one is going to be running on a different system, so I just have to switch the operating system and architecture. Other than that, we're gonna be again running in debug mode and skipping symbols. So if we go ahead and generate this, okay, here we go. We have our implant. I'm gonna run this in a separate shell. Quickly spin up our listener. And here we go. So we have our session. If we type the sessions command, we can actually get some information about currently running sessions. We also have the implants command, which is going to have a similar output. Using the use command, you can actively interact with that particular session. And then if you tap help, you can now see we have all the different commands that are available for that particular implant type. What I mean by that is, in this case, we're running on macOS. So we're only going to have the commands that are available on macOS. If you're running this on a Windows host, you would see, for example, commands under execute assembly or some additional things for buffs. But you're not going to see this here since this isn't supported on this particular operating system. Now, if you look at some of the commands, you have all the typical ones, like, for example, things to interact with the file system, cat, cd, download, and so on. For example, if I type pwd, we get the current directory we're running in. Similarly, you can also download, upload, and generally perform tasks on the host. If I type ifconfig, yeah, you can see any output from my local host the implant is running on. On the implant end, what we can see here is our implant is periodically calling back every few milliseconds, generating a different URL which is callback. And one thing to note here is that each of these URLs is going to have a small parameter here. I'll explain a bit later what this is specifically about, but essentially this is the basic way the implant works. Now let's take a look at what is actually happening behind the scenes here. So when we initially start our Sliver implant, it's going to create a folder in the user's home directory under .sliver. And that folder is going to hold the configuration options, the different implants that we generate, and the database of our current session of Sliver. So if I go ahead and go into .sliver, let me quickly do this here instead. So most of the files that you're going to see here are some dependencies of Sliver, for example, adjectives.txt, that is used to generate the names of the different implants. If we look at builds, you're going to see a UID here. This is the implant that we built earlier. If we run a quick file command, you can see this is the Mako 64-bit executable. You can also find this same implant under the Slivers directory. So if we go in Slivers ARM64, these are different implants that I've generated on my local host, and we have the one that we generated here. Under bin, you're going to have another copy of that same implant, and then under source, you're going to have the source code of that implant. When you generate an implant in Sliver, what happens underneath the hood is that the binary creates a copy of the implant code, and then it's going to embed into that code all of the configuration options, as well as some cryptographic keys that are going to be unique to that particular Sliver session. One thing we'll also see later on is if you use a custom C2 profile for this, at this stage, this is also going to be embedded inside the source code before it is built. So each implant is going to have a different configuration, different keys, different C2 profile, and be a bit unique. So if you rerun generate with the exact same parameters, it's not going to be the same implant behind it. It's going to have a different key, different keys for communication, and a different configuration for its callbacks. But we'll get into that a bit later on. Now, another very interesting folder is the logs folder. So one issue that we regularly run into during engagements is sometimes we need to work backwards and figure out how exactly we did something, build a timeline of our activities, our commands, and it's not always that easy. So one thing we've been working on is improving the Sliver logs. Up till the previous version, all you had was these files here, so the audit.json console log, sliver.json and sliver.log, which if you run a quick tail right now, is showing you the current implant calling back. You can have the URLs, timestamps, user agents, and so on. But it doesn't really give you a ton of details about what is really running behind the scenes. If we take a look at audits, we do get the different commands that are being run. So you have some level of detail, but it's not necessarily very easy to see what is actually happening on the system. One improvement that we implement in this next version is underneath clients. We record all of the commands output as well as ASCII cast of all of the individual client sessions that are running. So, for example, if you run ASCII Cinema on this ASCII cast output, you can see here the different commands that were run in the order, as well as any output that we get from them. It's a bit garbled, but you get the idea. And similarly in JSON, the JSON output, if we just take a look here, is the same thing, but in a different format where you see the different commands that were run. And you can also see the output of those commands. I ran a pwd command, and you have the output right here, as well as a timestamp of what that command was. The result of that command was received. So, moving back to our server. If we type the background command, we jump back to our main Sliver CLI, and we'll go ahead and spin up another listener. So we now have HTTP and HTTPS. If we look at the commands that are available, another one that we have is what we call multiplayer or multiplayer mode. One thing to keep in mind when you're using a framework like Sliver is you're going to have multiple operators working at the same time. They all need to have access to the implants, and they all need to be able to move back and forth, running commands, sharing details, and so on. And what we use for that is something that we call multiplayer mode. If you run this command, it's going to spin up a new listener here. which you can see now running on port 31337. It allows operators to use the Sliver client to connect to the server. All you would need to do at this point is use the new operator command to generate a new configuration file, which then, when used with the Sliver client, lets you connect to the server and run commands interactively. So this is the very basics of how Sliver works. We're going to delve into some more details of the different types of implants that are supported and so on in our next section here. Right now, we're still going to spend a bit of time in the .sliver folder. If I go back here, one other folder that I did not mention was the configs one. You can see a series of JSON files here. These essentially allow you to configure some of the options server side. For example, by default, we use an SQLite database for Sliver, but if you want to use MySQL or Postgres, you can modify database.json, configure it with whatever backend you want, and it'll be using that one instead. Server.json lets you configure some options for the Sliver server itself. For example, you can run it in daemon mode and then only use the Sliver clients. This is mostly useful if you have some automation in place. One thing we do, for example, is for each operation, we'll spin up a new VM where we'll be running Sliver in daemon mode, and then all of our operators will be using the Sliver client to connect to that server. Once the operation is done, we can then just wipe it and move on to the next one. You can also configure things like the log level or individual features, like, for example, Watchtower, which we'll explain in a follow-up session, or headers. This here is some of the default responses that you get if you try to query the HTTP server without necessarily having any valid ID or session ID. But again, we'll go into this in a little bit. Now, Sliver currently supports two types of implants, sessions and beacons. Right now, what you've seen was the session, which is a very interactive type of implant. As you can see here, it's constantly connecting back every few seconds. What's happening under the hood is that the implant is maintaining a TCP long pooling connection. So it's sending requests every few milliseconds to keep that TCP connection open and constantly communicating over it. It has some advantages and disadvantages. The main reason why you would want to do this is because of the high amount of requests happening, you can do some pretty network intensive tasks. Like if you're downloading larger files, or if you're trying to use a SOCKS proxy, this would be the type of implant that you would want to use, because otherwise you might run into latency issues. The other type of implant that we have is the beacon. So the way you generate it is similar to sessions, but rather than using the generate command, you can use the generate beacon command. So we'll go ahead and generate a beacon to demo that. And again, run it in a separate shell. So if I now type the beacons command, you can see we have a beacon that connected back. And similarly to sessions, you get some metadata about what is going on. So the current directory, the name of the device, the username, and so on. And similarly to the session, with the use command, you can interact with it. Now, one thing that I didn't show you earlier is filtering and completion. So one thing that we also included in our upcoming 1.6 release is the rewrite of the CLI, which was provided by a community member and a pull request. I don't exactly remember his name right now. I'll have to add it in the chat later on. But what this enables you to do is to just filter based on whichever parameter you can see here. For example, if I want to only see sessions, if I type session, it'll filter it down to that. Or if I want to have a specific username or a specific implant name, I can just type that in. It'll filter it down, and then I can hit enter, and I will be interacting with that implant directly. In terms of commands, it's pretty much the same thing you would have with a session. There are just a couple additional ones that are beacon specific. I'll get to that in a second. But one thing to note right now is if I type a command, I don't get an interactive response. Instead, we're going to have to wait for a bit, and then once the task completes, we get that output. If you look behind the hood, what is actually happening, this implant is periodically sleeping and calling back every 60 seconds with a maybe 30-second jitter by default, retrieving any requests to run commands, running them, and then providing the output. So this is a lot slower than when we're running a session. The main purpose of this type of implant is, well, this is similar to what you would see in Cobalt Strike, for example, to maintain a very low network footprint and try to mask your communications. That way, if you have a longer term implant that you've left as a backdoor, for example, you can have it call back maybe once a day, once a week, whatever you want really, and try to avoid raising any suspicion from a network communications perspective. So switching back to our shell. If we type the info command, we can see some details about the current beacon. The first time it called back in, the last time it called back in, the next time it's going to call back in, as well as the current configuration for the interval and jitter. So I saw a quick question here in the chat. As far as ways to make the implant smaller, that's something that we're currently working on, but right now it's not a possibility. The way we usually manage that particular problem is we use stagers, which are going to load an encrypted and compressed version of the implant in memory. That way, the size is not necessarily as much of a constraint, and you can have a really small stager that bootstraps the whole process and loads our larger implant later on. Like I mentioned, this is not really what you would use for initial exploitation, but rather something that you would use once you already have access to a system. So the size constraint is a bit more manageable. That being said, it is a concern, and it's something that we're planning to work on for the next release. So going back to our beacon, one command that you can use to interactively change that configuration is the reconfig command. If we want to update the interval and jitter, for example, we can use reconfig -i for 5 seconds so that the interval becomes a 5-second interval, and then -j for 1 second so the jitter is 1 second. So if we go ahead and hit that, the next time the beacon calls back, it'll reconfigure itself and then adhere to that new configuration. For those that don't know, so the beacon callback is the static leap time we're going to leave between subsequent calls. But if we had it hard coded at 30 seconds, it would be fairly obvious to spot that this is the beacon calling back. So we also have something called jitter. This is something that you'll see in similar projects like Cobalt Strike, Nighthawk, and other implants. And it's going to randomize a bit more and do a plus minus of that initial sleep time with some randomization added in here. So with this configuration, it's going to be 5 seconds plus minus 1 second, and it's going to be anywhere between 4 and 6 seconds, essentially. Now, we can see that it reconfigured itself. So if we retype info, we can now see the new interval and jitter has been picked up by the beacon, and it's running that. If we can use the tasks command to see all of the commands that have been run on a particular beacon. Right now, we can see there are 2 tasks, the reconfigure command and the pwd command. If we use tasks fetch, we can retrieve the output of a particular command as well as timestamps, request size, and a few other details. So this lets you, for example, take a look at what another operator has been doing using a beacon if you're multiple people using a beacon at the same time. Now, as I mentioned earlier, beacons are typically what we use for our long haul access, and sessions are what we would use if we need to run some more network intense activities. One way you can switch between both of them is to start by deploying a beacon and, for example, set up a systemd task to run that beacon periodically so that you can maintain access. Whenever you need to go active and, for example, want to run, I don't know, blood on a system, for example, you can use the interactive command. If you run that, it's going to spin up a session inside the same process and run it as a separate thread. So you can see here, I ran interactive. It picked up the task. If we type in tasks, we can now see we have the open session command that's been run and completed. And we can see we have a new session here that just called back in. So if I add background and then type use, we now have that new session here. Oops. And I can now start running, for example, a SOCKS proxy using the SOCKS 5. And we can now have our SOCKS proxy and route our commands through that session. And then once we're done with all of that, we can then kill that particular session using the close command. At which point the session is no longer available, and we only have that initial one that we spun up at the very beginning of the workshop. That way, we can make sure that we only have a higher network footprint when we specifically need it, and otherwise we leave a smaller footprint using our beacons. One thing to keep in mind is if you kill a session, you're going to lose both your session and the beacon that spawned that session because they're both running in the same process. So you need to make sure that you use the close command so that it only kills that specific thread rather than the entire process. Let's see. Looking at the chat, we have another question around generating stagers. So we did overhaul the way stagers are generated in Sliver, but we also removed we overhauled the way stagers are written, specifically the way it generates shellcode. But we removed the MS Venom integration from Sliver because it was basically just a wrapper around the MSF Venom CLI and was generating more bugs than was actually solving problems for us. At the end of the day, you can still use MS Venom to generate your stage if you need, or you can use any other tool. But what we did was rewrite the staging feature so that you can just host your shellcode binary inside the HTTP listener and call it back. This is something that we'll probably cover in a subsequent workshop, depending on time. We'll see if we can get there today. So we talked about sessions, we talked about beacons. Let's delve into C2 profiles. So one thing, one limitation that we had up till now in Sliver was, in case you're familiar with it, you would have to edit a JSON file for a C2 profile of all of your implants, and then that would be reused across all implants that you generate in that particular session. You're also constrained in the way Sliver did network communications. For example, it had 4 different extensions that are used during the initial session setup, during its polling and so on and so forth, which makes it fairly easy to fingerprint what is going on. If you look at the default network profile and somebody didn't change that, you can quickly figure out what their implant is actually doing. So one thing that we did in 1.6, and this is currently in GitHub, just not released yet, is add an option for C2 profiles. So one of the newer commands that you're going to have is C2 profiles, which right now just shows you the default profile that is configured inside my current Sliver session. You can see the different options that we have, for example, file extension, pass files. These are all variables that are embedded inside the implants and used when calling back. If you look at our session here that is calling back, the different URLs use the values of that profile. For example, here we have a .js extension and we have a route file name. These are all values that you would have here inside our path and files. All of this is now configurable in the sense that you can have multiple profiles running concurrently. And all of that kind of works under the box. Now I'm gonna do a quick demo of that and show you what that looks like. So C2 profiles has 3 subcommands: import and export, so you can have a JSON blob of a profile that you can then edit and re-import and then generate, which I'll show in a little bit. So if we go ahead and run an export, just give it a file name. In this case, we'll just use default, and the profile that we want to export, which is also the default profile. If I open another shell and open that file, just quickly clean that up. Okay, here we go. So this is a JSON version of that same C2 profile. We can go ahead and edit any of these fields and re-import it later on. A couple things to note are these 4 values here. So max files, min files, and max path, min path. If you remember at the beginning of this session, what I mentioned was when you generate a beacon or a session, the backend embeds a series of values inside the implant. It's going to copy the files and paths, but it's not going to copy all of them. It's going to copy a certain number that is randomly selected. So right now the max files and min files is 2 and 4, so it's going to copy between 2 and 4 files from that configuration file. So this is how we can generate different types of implants because we embed different values in them that are randomly picked when we generate them. That way we avoid repetition, we avoid having 2 implants calling back using the exact same values. Instead, we embed random values picked from our profiles, and then we procedurally generate those URLs so everything is more randomized and it looks a lot less static. You can't just sort all of the requests and try to figure out, okay, this callback does that. This doesn't really work with Sliver because everything is procedurally generated. So let's go ahead and create our own profile. One thing that I typically do during engagements is we'll first have an external portion where we'll look at our target's external infrastructure, scan any assets that they have, look at web applications, trying to find vulnerabilities. And so we're going to keep track of all of that, all of the URLs that we've seen. And we're going to have that in a file. So for the example here, I'm just going to pull a list of URLs from SecList for WordPress. If you take a look at this is just a list of URLs. And when we're running an engagements, we typically like to keep a similar copy of applications that our target uses. That way, we can have our implant mimic those connections and essentially make them look more legitimate. So right now we have this list of URLs. If we move back to our CLI, we're going to use C2 profiles generate to generate a profile based on that list. I just need to give it the name of the file here, which was URLs just WordPress. And we're going to call this C2 profile WordPress. The template here is the C2 profile it's going to use as the basis for the new profile. So it'll basically copy all of the values from the currently existing profile into it. So, and then finally, the -i flag to import it. If we now type C2 profiles, you can now see we have a second profile available, WordPress. And if we hit enter, it now has all of the file extensions, paths, and files from that file that we used to generate this profile. So as a next step, we'll quickly export this. So we'll call this WordPress profile. And here we go. So if we now open up that file, quickly clean that up, we'll change a couple of the values here. For example, instead of 4, make this 40. And we're going to change the lengths here. So these are 2 values that I didn't mention yet, max path lengths and min path lengths. If you look at our session currently calling back, it uses, it looks like it's using between 2 and 3 values for the pass. These values can be configured in the profile using these 2 variables. So I'll just go ahead and switch this to 1 and 3, just for demonstration purposes. We also have all of our extensions and files, like I mentioned, and then we have the nonce. Now, when Sliver is communicating with our C2 server, it's not just sending back plain text copies of the output of our commands and things like that. Instead, everything is first encrypted and then encoded into different, using different encoding schemes to try and mask that traffic. For example, it can use images where it's going to hide the encrypted data inside what looks like a PNG image, or it's going to use hex encoding or gzip. But the C2 server still needs to be able to figure out what encoder was used so it can retrieve the plain text version of that to then display it to you in your server command line. And this is done using a nonce. Inside of this value here, there is a number which we then process a bit using a modulus to identify a particular ID that is tied to a particular type of encoder. These IDs are regenerated every time you rerun a Sliver server, so they're going to be unique to your server session. But this allows you to allows the server essentially to know what type of encoding scheme was used, and then to be able to decode, as I mentioned, decode that data and properly process it server side. This is also why each request here has a HTTP parameter, which in each request is 1 character randomly selected, followed by a number. If you take a look at the profile, one of the new options that we've included is something called nonce query lengths. So if you want to randomize that and instead have a query length of 3, it will use 3 parameters, 3 letters for that HTTP parameter instead of including just 1. Another feature that we've added is something we call nonce mode. Instead of just embedding everything inside an HTTP parameter, we can now embed it inside of the URL. So we'll go ahead and save that and then re-import it inside our Sliver session. So if we take a quick look at the import command, we give it the file containing our profile, as well as the name of our C2. And then finally, we tell it that we want to overwrite the current C2 profile configuration. So quick check, and everything has been properly overwritten. Now, one thing that you'll notice is I never actually had to restart any listeners or anything like that. Whenever a profile is imported inside of your CLI, it's going to be automatically added into any listeners that support that particular type of profile. So in this case, the HTTP and HTTPS profile listeners, sorry, and directly support it. So really all we need to do at this point is generate either a session or a beacon using that particular profile, and it'll be able to communicate back. And you can have multiple profiles running concurrently, depending on what you want that particular beacon to do. So one way you could take this, for example, is have a profile for a particular type of target. If you have a beacon running on a laptop or a beacon running on a Windows server or another one running somewhere in the cloud, you don't want those to all be using the same type of URLs or calling back over the same endpoints. Instead, you want to try and customize this. It doesn't make sense for a process on a Windows server to call back on Discord or Slack. That just looks weird. This shouldn't be running there. Instead, you could have it call back over a random AWS service if you want. And so the whole point of this is to allow you more flexibility in the way your implants are going to be connecting back to your infrastructure to try and better mask things and also split things out so that even if one implant ends up being caught, that doesn't necessarily mean that they can just block you or block that particular type of traffic. So let's go ahead and take a look at what that looks like. Again, we'll first start with a session and then we'll use a beacon. So the command is going to be pretty much the same as the previous one. We'll use our generate session, and we'll just add a C2 profile parameter. If we go ahead and type tab, we can see it autocompletes and shows you the available profiles. We'll just use the WordPress one and hit generate. If we now open up a new shell and just run this, we should now have a new callback. And we have our session here. If we type use, we can just quickly filter it down to that. And we can just interact with it and run commands. Taking a look here at the debug output, we can see that there no longer is a URL parameter now. Instead, the nonce is embedded inside of each URL. We can also see that the extensions have changed. It's now using our new profile, and it's now using WordPress paths and files. If we wait for a couple of seconds, we should be able to see something from WP admin or something a bit more obvious. Anyhow, so this is how this whole feature ties together. If we take a look at our .sliver folder, as I mentioned earlier, one of the other improvements that we've done in 1.6 is we've integrated a lot more features inside of a database. So, oops, all of this information is going to be saved inside of that SQLite database. And this is essentially how we're able to interactively load all of this. Whenever our server receives a request, it's going to be able to use that database to try to determine, okay, what profile is calling back? Does this match to an implant that we use? Is that session live or not? And based on this information, the server is enabled to determine whether the connection is legit or not, and allow you to access, allow you to interact with it or filter out the request as something that looks weird instead, essentially. Okay, so this is the initial section I was planning to cover today, but since we still have about 15 minutes left, I can quickly go over the generation that I mentioned earlier. So we talked about how to create beacons and how to create sessions. The issue we've had here is for each time we want to generate a new command, we need to specify all of our parameters. Instead of doing that, one thing you can do is create what we call a profile. So a profile is essentially a way we can save the parameters for a session or a beacon. If we use the profiles new command, we can give it the exact same parameters that we would give when creating a session, for example. So I'll just go ahead and just create a profile for a session using the same parameters that we've used previously. So skip symbol debug and give it a name. I'll call this one macOS 1. If I now hit profiles, we now have this particular profile configuration saved. And then we can go ahead and hit profile generate, give it a name, and it's going to create that session. And we can hit that as many times as we want. Again. So if I now type implants, looks like we have a small bug here. All right, let me just quickly restart the server, see if that fixes it. All right, looks like we had a small regression here. I'm not going to be able to show everything, but essentially every time you hit profile generate, it does the same thing I mentioned earlier when we run generate. Essentially, it copies over the implant code and embeds those values. So this is if you need to generate, for example, 5 different implants that use the same configurations, this is the way you would use it. You you generate your profile, and then you type profile generate, and each implant that you generate is going to have that same basic configuration. but it's still going to be slightly unique in the sense that it has separate keys used for its communication and so on. It's also going to have a slightly different C2 profile since that is generated and embedded during compilation. And so this allows you to, for example, have one implant per host that you compromise if you want. Cool. So we've talked, let's see. All right. One last thing that I'm going to mention is we're also currently in the process of rewriting our documentation. We've set up a small website for this, which you can find here under sliver.sh. So if you go ahead and browse there, you'll see current version of the documentation. Under tutorials, you'll also see thank you, Moloch. You'll also see the current version of the tutorial. Most of what we've covered today are going to be the chapters 1 through 3. In subsequent versions of this workshop, we'll cover, as I mentioned, staging using pivots, and then we'll get into scripting and how to use automation to interact with beacons and sessions. So we're gonna close it off for now. I'm gonna open it to the floor for any questions or anything that you'd like to see in more details. And then in next session, we'll pick up with staging and rerun through that demo that I mentioned. So any questions or anything that you would like me to delve into?
Yeah, feel free if you have any questions, you can pop them in the chat, or however if you ping us or any of that. Feel free to let us field those for you. I'm back. Oh, there we go. Asked and answered. Can I build 1.6 from source on ARM64? And that is a yes. But yeah, thank you so much, Tim. That was great. Great presentation. I think we got a lot out of this. A lot of questions throughout in the chat. So thanks everyone for participating. I hope this was super useful. We got several people typing, so we'll give them a second here. Okay, let's see. Okay, yeah, and we've got more sessions coming. So don't forget, we will be back in. We don't have the dates nailed down just yet, but within the next few weeks, we'll be back for some more training on this, where we can dig into more features in depth too. Recommend any trainings that will help to learn more about Sliver. Come to our next one. Also, no, the site that Moloch shared in there, right? That's got a few more tutorials?
Yeah, the tutorial is basically the version I give in conferences. The one that's live right now is from last year, but we can. I have a pull request pending. We'll get that out somewhere today.
RDP with the socks proxy was not working. Is that now better? Hmm.
Yeah, RDP is still very much an issue with the current socks proxy. We have a pull request with some improvements there, which should help, but not 100% sure whether that was finally fixed. Typically, what we do is we'll use a separate binary to call back. We like to use Chisel, which works quite nicely, but it has its own limitations. For example, it uses WebSockets, so it's not necessarily usable anywhere. But yeah, RDP is definitely a bit of a problem with our proxy.
All right. Well, with that, I think we've answered any of the burning questions we had in chat. Like I said, if anything pops up later, feel free to drop them in the Sliver chat. We're in there every day, just hanging out, so we can definitely address that. And if we see stuff come up in there, we can maybe try to kind of work that into some future workshops as well as we kind of plan that out for you. But big thanks to everyone who showed up today. This was a lot of fun. I'm glad we had good turnout, and huge thanks to Tim as well for doing this. This is very meaningful for a lot of these folks, and I think we did them some good today. So thank you, and we will see you next time in our next workshop. Thanks a lot.